Yes, good day, class. I welcome you to our another topic of today's series in parallel circuits, which you can find in your textbook from page 139 to page 143. Just to start with, without wasting time, let's talk about the series circuits. In the series circuit, the current remains the same throughout the circuit. The current, it remains the same throughout the circuit. As more resistors are added, the current decreases. As more resistors are added, the current decreases. In this case, again, you should understand that the voltage is split between the resistors. Voltage is split between the resistors. In this regard, again, understand that the highest resistance is the highest voltage. The highest resistance has got the highest what? Has got the highest voltage. So for series circuit, the current remains the same at any point in the circuit. Current remains the same at any point in the circuit. Any point at the same at any point in the circuit because it only has one path to flow. I'm sure that, please note this, we are saying not that the current remains the same because it only has one path to flow. It can only be calculated with the formula A1. Current, we are saying A1 is equals to A2 is equals to A3. A1 is equal to A2 is equal to A3 because the current remains the same throughout the circuit as it is going to follow or flow through the same singular path. And the potential difference is divided between the resistors in relation to the resistance. Potential difference is divided between the resistors class, between the resistors in relation to the resistance of each resistor. The potential difference over all of the resistors is equal to the total difference over the battery. The potential difference over all of the resistors is equal to the total potential difference over the battery. It can be calculated as follows. We are saying Vt is equal to V1 plus V2 plus V3. That is equal to what? We are saying V1 plus what? V1 plus V2 plus V3. And then what we are saying is that we'll get our what? Our potential difference. What is happening is that the voltage, the total voltage for the circuit is measured by the voltmeter over the battery. Total voltage, I'm sure that you understand that the voltmeter, it is actually used to measure what? The total voltage over the battery. And then V1, V2, and V3 is the voltage through each of the individual resistors. The V1, V2, and V3, I'm saying these is the voltage through each of the individual resistors measured by the voltmeter over each of the resistors, which we are given an example here, as to say V1, V2, V3. So, the current is divided in inverse when we are looking at when we are looking at parallel circuits. Parallel circuits, the current is divided in inverse proportion to the resistors, which I'm saying you should see that where it is throughout the current. For parallel circuits, the current is split because they are now multiple paths to take. Current is split because there are multiple paths to that the current can take. The amount of current, which we are saying here, the amount of current, you must understand that the amount of current in this case, the amount of current will be inversely proportionate to the resistance. Amount of current is inversely proportionate to the resistance, so that the most current will flow from the weakest resistor. The weakest resistor is the one that has got what? That is the most current flow. It can be calculated with the formula which is equals to what? A1 plus A2 plus A3, which is given there, and then the potential difference remains the same. The potential difference remains the same throughout the circuit. It can be calculated as what? V1 is equals to V2 is equals to V3. That is to say that the potential difference is equally the same, even if we are in the parallel circuit. And then it is the total current of the circuit measured before the circuit splits. When you look at what you call the amount of current is equals to the total current for the circuit before, measured before the circuit splits. That is given as in cases like that. A1, A2, and A3 are current through the individual points, which we say A1, A2, A3 are individual current through the individual points in the circuit, which we are saying they are in what? They are in parallel. They are in parallel circuits. So let's look into this. We have got some, I have just attached some questions for reference here. Just look at these questions for reference, just to make sure that we can be able to refer and be able to calculate various questions or relate to what we have just done here. Using the formula, use the corrective formula, provide the value of for ammeter A, for ammeter 1, which is here, the ammeter 1 provides the what? The value of ammeter 1, which is given there with 2 marks. So I just worked it already and put the formula there. Ammeter 1 is equal to what? Ammeter 2. So we are saying A1 is equal to A2. A1 is equal to A2, and then which is equal to 2 amps, which is equal to 2 amps there. And then the next question is saying, using the correct formula, provide the value of the voltmeter 1, the voltmeter 1 above. So the voltmeter 1, which is above here, we are saying VT is equal to what? V1 plus V2. So our answer is equal to, say we are given 6 already here. 6 volts is given there. So we are saying our 6 volts is equal to 6 volts is equal to V1 plus 3, which is our voltmeter 2, which is given there. And then which is equal to, say this is just a simple this question, this part here is just a simple mathematics or equation where we are saying 6 is equal to V1 plus 3, and then we want to find V1. So we just say 6 minus 3 is equals to what? Is equals to V1, and then 6 minus 3 is equals to 3. 3 is equals to V1, which is given in this regard there, which is given there to say, wait, how are we getting 3? It's just an equation that is just which is just solved, which is being solved in this regard. And then calculate the resistance of one of the light bulbs. Both light bulbs have the same resistance. Calculate the resistance, which is equal to voltage is equal to what? Resistance times current. Voltage is equal to what? V is equal to IR. So our voltage is equal to what? Is equal to 3, which is equal to 2R. And then we want to calculate what? R. We divide by 2 both sides, divide by 2. So therefore we can get 1.5 ohms is equals to what? Is equals to R. That is where you are getting this what? This is this 1.5 volts there. So these questions, I'm just calculating them for you. So therefore you can be able to relate and be able to see And again, when they come next time in question, you can be able to answer them. I hope you have understood this, and thank you very much for following and watching. Don't forget to share and also subscribe. Thank you so much.